Math 2, Unit 11.1. Today we're just talking about adding and subtracting polynomials. Does anybody know what polynomials are? No. Multiple terms. Okay? Yeah. So there's actually, if you go through here, there are monomials. Monomial has how many terms? One. Very good. So monomial is one term. We also, it doesn't go through here, but there you need to know that there are binomials. Very good. And there are, very good, trinomials, which have 3. And then the rest we're going to refer to as polynomials. And so for the most part, really a monomial is also a polynomial. Polynomials encompasses all. Okay, so but normally what we're going to end up doing is that a monomial has 1, binomial has 2, trinomial has 3, and then anything past that you would just classify it as a polynomial. Okay? All right. Each of these terms right here are monomials. They are single terms. Do you notice how this has a number and a letter with it? They're all together though. And so that is considered a monomial. A binomial is when you have 2 separate terms. Terms are always separated by adding and subtracting. Okay? And so anytime you have a plus or minus in an equation, it's separating the terms. And so then you'll know that there is more than one term. Okay? Degrees. Degrees are based on your variables, and specifically however many exponents there are with the variables added together. Okay, so again here, your degree is the sum of the exponents of its variables. If you have a number, is a number a variable? Like if I have the number 5, is that a variable? No, a variable is a letter. Okay? And so this degree is 0. When you're trying to find the degree of a polynomial, right here, the degree of a monomial, okay, is the sum of the exponents of its variables. If you have a number, a constant, like 5, it has a 0 degree because there's no variables in it. Okay, now let's go down here to A. Do you see how X and Y are variables? Yeah. Okay, I can hear someone's music and it needs to be turned off. Okay, so these are variables. 1 plus 1 is how much? 2. So this degree is 2. Okay, is X a variable? Yeah. If it doesn't have an exponent, it has an exponent of 1. Okay? And so the X has an exponent of 1 and the Y has an exponent of 1, and you add all of those together. 1 plus 1 makes 2. Now on B, 27 doesn't count. We're only looking at our letters. So Y has an exponent of 4, and what does Z have an exponent of? 1. So what is this degree? 5. 5 is correct. On C, does it have any variables? So the degree is 0. Are we okay? I'm hearing no's. Okay, shh, I need to take questions. Okay, Aaliyah, ask me. Oh, there's a Z right here. You just can't see it. So it's, and so you're looking at the exponents of the variables. So I'm going to make this bigger here for a second. This is 27y to the 4th Z. And so 27 doesn't count, but y to the 4th has an exponent of 4. And then Z doesn't have an exponent, which means it's a 1. And so we added 4 plus 1, which makes 5. Does that make more sense? Okay. Does anybody else have questions? Okay, let's move on. So now we're on page 640. Okay, so on page 640, it states that you can add or subtract monomials by adding or subtracting like terms. Now, we have added and subtracted like terms. When you're adding and subtracting like terms, I always say the last name has to always be the same. Everything has to look the same in order for you to add or subtract it. So like 5x plus 5y, could I add those together? Yes. No, because one has an x last name and one has a y last name. Also, if I had, let's say, 5x plus 5x squared, looking at this last name, this one has an x, this one has an x squared, not the same. So I couldn't add those together. I can only add them together if they are exactly the same at the end. You know how the end of our name is our last name? That's why I just say the last name. So this ending part has to be exactly the same in order for you to add or subtract it and put it together. Okay? So this says, what is the sum of these numbers? And so this is a negative 6x to the fourth plus 11x to the fourth. Do those have the same last name? Yes. Yes. So what is negative 6 plus 11? 5. So that's my answer. 5x to the fourth. Okay, so we're just looking for like terms. That's it. Okay? This says, what is the difference? It's just subtracting here. Are the last names the same? Do these look exactly the same then? Yeah. Yes, so what is 2 minus 7?
Negative 5.
Good. Negative 5, and then you keep the last name the same. We're not multiplying, so everything stays the same. Any questions?
Nope.
Okay. Number 3. What happens when there isn't a number in front?
It's a 1.
It's really a 1 there. So what is the answer for number 3? Good. 9w to the second x. What is the answer for number 4? Good. Perfect. Does anybody have questions there? Okay, we are still on page 640. It says a polynomial is a monomial or a sum of monomials. The following polynomial is the sum of these monomials. There's 4 of them. Okay? So if you look at this problem, in order to find the degree, okay, you always look at the highest exponent. So what they're saying for each of these specific terms, this one has a degree of 4 because the exponent's 4. This has a degree of 2, the exponent's 2. Degree of 1, exponent's 1. There's no variable, so it is a 0. Okay, the polynomial shown above is in standard form. Okay, standard form of a polynomial means that the degrees decrease from left to right. Okay, so see how it starts with the 4th power, and then it goes to the 2nd, and then the 1st and 0. You always start with your highest degree and go down. Okay? The last thing is the degree of the polynomial is the same as the degree of the monomial with the greatest exponent. So the degree of this problem right here is 4. So you always look for whichever term has the highest exponent, and that is the degree of your polynomial. The highest exponent in this problem was 4, so therefore the degree of that expression is 4. Are we okay with that? All right, we're going to move on. Okay, we're now on page 641. So looking right here, they just have a table for you. It says name using degrees, number of terms that the equation has, and then the name using number of terms. So remember how we talked about 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, okay, and so on and so forth. Okay, you can also see that here, the number of terms it has. See how it's separated by a plus or a minus? This has 2 terms. This one, 1, 2, 3 terms. Again, terms are separated by pluses or minuses. It has 3 terms. There aren't any pluses or minuses separating different terms. This one, 1 term, 3 terms. We good? Okay. The degree is always dealing with the highest exponent. On this one, the highest exponent is 1, so the degree is 1. Here, if you look through this, the highest exponent is 2, degree is 2. Highest exponent is 3, the degree is 3. Highest exponent on this one is 4, degree is 4. Okay, so this is a good table to come back to just kind of give you examples of what things are. All right, so got it, part A. It says, write this expression in standard form, and then what is the name of the polynomial based on its degree and number of terms. Okay, so we first want to write this in standard form. That means highest exponent to lowest. Also pay attention to negatives, because if there's a negative in front of a term, then you want to keep it in front of the term. So what would be the first thing that I'd write? Good. 8x squared, and then what comes next?
2x.
Good, and that's a positive 2x, and then minus 3. Okay, so for degree, I'm just going to put a D, and we're going to state, what is the degree of this problem? 2. And how do I know it's a 2? Very good. The highest exponent is 2. That means the degree is 2. What would I name this? Using, how many terms are there? 3. So it is a trinomial. Bless you. Okay. Any questions? All right, B, reasoning. It says, how does writing a polynomial in standard form help you name the polynomial?
You can see it.
You can see what the highest exponent is.
So I like that. You can see what the highest exponent is. Okay, you guys ready to move on? Still on page 641. All the little side conversations need to stop, please. Okay, so we're going to do the same thing again. So you're going to write each polynomial in standard form. Then you're going to name the polynomial based on its degree and number of terms. So there's a couple things you need to pay attention to here. When you're writing in standard form, you want to add any like terms together. So I always start with the highest exponent. What's my highest exponent right now on number 5?
2.
Good. So we have an x squared. Are there any others that match that with an exponent of 2? So we're going to combine those together. So what is 6 minus 13? So we have negative 7x squared. From there, the next thing I have, and sometimes if I go through and cross these out now, I know they're done. And then I can go through and write the next term, which is going to be what? Negative 4x. Good. And then we have plus 4. And I can't add any of those together because they're not like terms, correct? They don't have the same last name. Okay, based on that information, what is my degree?
3.
2, because that comes from your
The
highest exponent. And then how would I name this?
trinomial.
Trinomial. And how do you know it's a trinomial? 3 terms. Okay, any questions? Anybody have questions for me? Okay, 6. Highest exponent. What would be my first term? Good. Negative 3c to the 7th is correct. And did it have any other c to the 7th in this problem? No. Okay, what's next? Good. Plus 8c to the 3rd. That didn't match any. That one's out now. And then the last one would be plus c. What would be my degree on this problem? 7. Very good. And then how would I name this one? Good. And how did I know it's a trinomial? 3 terms. Okay, anybody want to ask questions? Trinomial is always in terms of terms. Terms are separated by pluses and minuses. And so see how this is 1 term, 2 terms, 3 terms.
Oh, it doesn't have to be a number? It can be like letters?
Yeah, so terms are separated by pluses and minuses. There really is a number here. There's a 1.
about the
1C.
Wait. So why would 5 be trinomial?
Again, they are separated by pluses and minuses. So do you see here, this is 1, 2, 3. 3 terms, trinomial.
Oh, it's just based on the number.
The number of terms. Okay, so when you're naming it, it doesn't have to do with your exponents or anything like that. It has to do with how many terms are there. Okay, any other questions? Okay, moving on, we're on page 642 now. Practice problem number 7. Wait. Yes. Here we go. Sorry. Okay, so what you have to be careful of here, and I'm going to show you a couple ways of doing these, maybe. When you have parentheses, if you have a positive here, and you were to distribute it through, it's not going to change any of the terms. But if you have a negative here, is it going to change the terms?
Yes.
Yes. Now, what I would suggest that you do is line these up with like terms. So I end up going like this, 5x squared plus 3, and then I have 15x squared plus 2. Do you see how the like terms are lined up with each other? And then I just add down. What's 15 plus 5? So we have 20x squared. And 3 plus 2 is 5. Let's not be silly. Okay? And that's my answer. Okay, if you notice on this next one, so the number of students at East High School and the number of students at Central High School over a 10-year period can be modeled by these equations. Okay, so here's East, here's Central. And each polynomial, x equals 0, corresponds to the first year in the 10-year period. What polynomial models the total number of students at both high schools? Well, what that means is they want you to add these together. Do you see how they're already lined up with like terms? Okay, so we could rewrite this if we want to, but I'm not going to. I'm just going to add down. So negative 11 and negative 7 makes what? Negative 18x squared. 133 and 95. What does that add to? Good. 228x is correct. Plus, and then 1200 plus 1100 makes 2300. So that is how many students with both of the high schools. Okay, on page 643 now, it says, recall that subtraction means to add the opposite. So when you subtract a polynomial, you will change each of the terms to its opposite. Okay, then add the coefficients. Coefficients are the numbers in front. So what I'm going to do here is I'm going to rewrite this negative 4m to the third. Now remember how we talked about going down in degrees? Do you see how there's no m to the second here? I like to kind of leave a blank for it because it helps me line up everything. So this would be my m to the second, but there is no m to the second. Okay? And then this would be m to the first, which is negative m, and then plus 9. Now, the reason why I did that is when you go over here, do you see how you have an m to the second now? And so it helps me for lining up my like terms. I also have to distribute this negative. So this first term is going to be what? Negative 4m to the second. So I'm going to write this as negative 4m to the second right here, where the m to the second term should be. Then we take this negative to the m, and that makes a negative m that I'm lining up. And then this negative goes to negative 12, which makes a positive 12. And my like terms are lined up. So you just have to be careful because m to the third and m to the second are not the same. So when we add, we get negative 4m to the third minus 4m to the second. What happens when you have two negative numbers? You add, but it stays negative. So that's going to be what? Negative 2m. And then 9 and 12 makes, what does 9 and 12? It does make 21. That would be the correct answer for that one. Okay. Any questions? Okay, so on number 9, do you see how they're already lined up for you? Okay, this is where some students make a mistake. What do you think some students, how do they make a mistake on this one? They do not distribute the negative. And so if you want to rewrite it, you can. If you can distribute it, and so you know that c squared will be minus, this minus 10c will end up making a positive, and then the 4 will become a negative. And then you can add down. So 2c squared minus 1c squared makes, good, and you can write a 1c squared or just c squared. 7 and 10 make, good, 17c, and then negative 1 and negative 4 make negative 5. And that is our answer. Okay. You guys, I realize some of this is easy, but just a couple more minutes of being quiet, please, unless you have a question for me. Okay. So on 10, do you notice that they're not lined up correctly?
Yes.
So we're going to write it out, I think, and line them up. Now again, do you guys see how this one has a 4th power and this one has a 3rd? I would make the blanks when we're lining them up so that we're going to line up our like terms. So the first one, I don't have anything to distribute in the front to everything. So my first parenthesis stays the same. But when I write it, I'm going to go negative 6w to the 4th. I'm going to leave a blank for my w to the 3rd. And then I have w to the 2nd, a positive w to the 2nd. On my next parenthesis, I have to distribute the negative. So a negative and a negative make a positive, and I'm going to line that up with where the w to the 3rd should be. So 2w to the 3rd. A negative and a positive here make a, so I have a negative 4w squared. And then here a negative and a negative make a positive w. So when I combine my like terms now, we have negative 6w to the 4th, a positive 2w to the 3rd. What happens here with the w to the 2nd? No. Good, that's a 1, right? 1 minus 4 is negative 3w squared. You always keep the last name, okay? You're only adding and subtracting your coefficients, which are your numbers in front. And then we have plus w here at the end. That's my answer. And also notice it's in standard form. It's descending. Okay. Any questions before we move on? Dustin, you getting this? Okay. All right, page 644. So first on 11 and 12, they just want to know what is the degree. So with your fingers, show me what the degree is for number 11. Good. Good. The degree is 4. How do I know the degree is 4? Because the highest exponent is a 4. Okay, what is my degree on number 12? Good. No. No, no. Yes, yes. Good. Good. Yes. Good. Good, good. Okay. The degree is where you add the exponents together for that term. So on this one, we're adding together 2 plus 3, which is 5. Now, when you have different terms where they're separated by pluses and minuses, then you take the highest one. Okay? But when you have each of your monomials, you add all those exponents together. Okay? Number 13. I'm going to give you about 15 seconds here to simplify that one. Okay, so if you lined up your like terms, I would line up 6r to the 3rd plus 3 underneath here. I didn't have to distribute a positive because it doesn't change anything. And we add down, and you should have got 11r to the 3rd plus 11. Any questions? Okay, same thing on number 14. I'm going to give you about 10, 15 seconds to finish this one up on number 14. I think you can do it. So it's x minus 2 minus parentheses 3x plus 5. Okay, so on this one, you should distribute the negative, right? So when I do that and I'm going to line up my like terms, this makes a negative 3x. And then this becomes a negative 5. So when you're combining your like terms, you have a 1x minus 3x, which makes negative 2x. And negative 2 and negative 5 make negative 7. Okay, do we have questions there? Okay, number 15. It says name each polynomial based on its degree and the number of terms. Okay, so on 15, tell me what the degree is first by showing me on your fingers. Good. The degree is 2. Now you name this by how many terms it has. How many terms are separated by pluses and minuses? So if you are counting terms, there are 1, 2, 3, which makes this a trinomial. Okay, 16, what's the degree?
1.
Good. The degree is 1. Again, when you're naming them, you're separated by pluses and minuses. This has how many terms?
2.
Which makes it a binomial. Any questions?